Hello everyone, welcome to Statics course in 2020. Today we will cover chapter 5.1, Conditions for the Rigid Body Equilibriums. So this is the first chapter of chapter 5, and some of you may realize that we already learned about the equilibrium equations in chapter 3. The chapter 3 title was equilibrium of a particle, but now we are looking for rigid body. Okay, so today we have two learning goals. The first one is identify support reactions. So you may remember that Newton has three physical law, and the third law was action and reactions. So if there is an actions, we have reactions. So that is support reactions. Let's look at this one shortly. And also I want you to know how to draw the free body diagrams for the rigid body case. Here we have a small particle. We're dealing with this information in chapter 3, and if you look at that, if this particle is unstable, then this equation should be satisfied. If you add up all the forces, which is the resultant force, should be equal to 0. Okay, if satisfy this law, then this particle is stable. But how about the rigid body cases? Here we have like a body. It's not a soft body. It's a very rigid. So there is no deformations. Okay. So in this case, we have to satisfy two laws. So first one is sum of all the forces should be equal to 0, and the sum of all the moment should be equal to 0. Why? Because this 0 for the force is meaning that there is no translation. If you add all the forces and the forces are equal to 0, then there is no translations. How about the rotations? If the moment, all the moments are equal to 0, then we can say, oh, this object is stable. There is no translation and there is no rotations. It is applicable to any arbitrary point O on the surface. Okay. For example, this is the simple example to explain the support reactions. Let's look at the figures. We have a nice airplane, and in terms of a two-dimensional point of view, by Newton's third law, we can say that the airplane has a weight, okay, and this is pretty rigid. Okay, so we call this is a rigid body, and there should be center of gravity of this airplane, and we can express using only one force. The force is the weight of this airplane that is acting on the center of the gravity. We have two wheels, rear wheels and front wheels. So we have two rear wheel force and one front force. We call this is support reactions. Support reaction. There is external forces and we have support reactions. So how to solve the problems? Like I said, you have to apply the two equilibrium equations. Sigma fx should be equal to 0. Sigma moment should be equal to 0. So we have to identify what is the unknown forces, what is unknown moment, and what is the known forces, what is the known moment. Okay, So here we have some beam, and it is fixed on the wall. Okay. And there is external forces which is known 1200 Newton downward from the 2 meters from the wall. Okay. And the beam has 6 meters. In this case, to solve the problem, we can think about the free body diagrams. So what is a free body diagram, guys? Free body diagram is showing all the known and unknown forces as well as moment. Here we have known forces, and this one is unknown forces by the weight of the beam. Okay, beam has a weight which is acting on the center of the gravity of the beam, and the location of the center of gravity should be 3 meters, because this beam is very uniform density, so that the center of gravity should be in the center. How about the moment? If there is external forces, then we have a moment here, right? Wait a minute. We have a moment. We have a moment. Okay. Then what is this one? If you look at this moment, this one is reactive moment, which means support reactions. Because if you look at this beam, beam is attached on the wall, so there are 2 support reactions. That is horizontal support reaction and vertical support reaction, as well as reactive moment. The moment was created by these external forces. Let's look at more examples. Before we go, you have to understand that the support prevents translation. Support prevents rotations. These are the key informations. Here we have a roller. Roller is very typical, typical support for the beam. Okay, this roller only support the vertical forces. So there is only one reaction forces for the roller. Here you can see this F is reactive force for the external force of the beam. So roller, we have only one force. How about pin? If you look at the pin, we call this is a pin joint. The pin joint has 2 restrictions. Compared to the roller, we have another restriction for the horizontal axis as well as the vertical axis. How about the rotation? In terms of the rotation wise, there is no restrictions. So pin joint has 2 support reactions. How about the fixed support? Fixed one is most restrictive way. This one has 3 unknowns. That is, we have a restricted for the horizontal and vertical, and there is restriction of the rotation. Let's look at the other examples. We have a cable. Cable has only 1 unknowns with angles. So this is the reactive forces. How about the roller? Roller has only 1 support reaction, but if you look at the direction of the support reaction, it should be perpendicular to the surface. This is perpendicular. How about the rocker? Rocker is the same. We have a perpendicular reactive force from the surfaces. These cases are the same. We have one support reactions. And how about this one? This one has only one support reactions. This guy is a smooth pin, okay, pin joint, right? So we have a two support reaction for the horizontal and the vertical. We can express these two forces using resultant force. This is the resultant force, and this is the angle. So we can express two forces with the resultant force and the direction. How about this one? Number 9. This one has two reactive forces. One is the forces acting on the rod. Okay, so we have a restriction for these directions, as well as there is restriction of the rotations. So we have a two support reactions for this case. So this is the two unknowns. This is two unknowns. This is one unknowns. Like I said, fixed support has most restrictive way for the support reactions. Here. Three unknowns. Or we have one moment, couple moment, and one resultant force with the directions. Before we draw the free body diagram, you have to express all the dimensions. So we have these examples. We have a beam, and there are three ladders on the beam, and there should be some external forces by the weight of the ladders. And we can express at the corner. This is the pin joint. This is pin, and this one is roller. And we have a certain dimensions here. So we call this is idealized model. Before we draw the free body diagram, we must express the dimension and what type of the support reactions. Remember, so since we are dealing with the some rigid body, and that the body should have a center of the gravity. To simplify the problem, we can think about this rigid body as a particle of this center of gravity. So all the forces should acting on this point. This is the resultant force. By the way, no, never mind. So this is the weight. This one has a weight. The weight acting on the particle, which is the center of the gravity. Let's look at another example. The truck ramp has a weight of 400 pounds each. So this one and this one has 400 pound weight. And this one is pin connected. Here we have a pin connected. There. And how can we determine the cable tension and the support reactions? Oh, we have a cable here. Okay. First, we have to draw the idealized models, which has dimensions and cable informations. And even though the figure didn't show any dimension and angles, we have to define based on what we measured from the real world cases. We can express that there is a dimension, and the center of gravity should be in the center, and the cable, and there are some angles. We have to show this information first, and then we can express all the unknown and the known forces. Since this is jointed as a pin, there should be two support reactions. And there is tensions by the cable, and there is weight by the ramp. Okay. So left one is idealized model, right one is free body diagram. It is very simple, very simple. So showing all the forces so that we can use these two equations to solve the problem for the 3D object, rigid body. Okay. How about these cases? Two smooth pipes, each having a mass of 300 kilograms and supported by, like this. There's an L shape, and we have a two pipe. I believe that the center of gravity should be in the middle, and we can express this. There should be some support reaction here, and there is two forces by the weight of this pipe, and there should be a support reactions like this. That is the perpendicular to the surface of this plate. So if we know the dimensions, please express these dimensions and angle informations. And here, this is the free body diagram. We express all the forces. We have two known forces, which is created by 300 kilogram times 9.8 meter per second square. So these two forces are external forces. We already know. These two forces created a support reaction, that is this one, and this one, and this one. The last question is a little bit tricky. So we have a rotation here, and we have external forces by this weight, and draw the free body diagrams of this bent rod. Here we have information about the smooth surface. This surface is smooth. Okay, so there is no frictional force at point B by a color A. Okay, which is the fixed to the rod and free to slide over the fixed. So there is flexibility, so we can move this up and down. It's free, but what is the restriction? Restriction is this way, because it designed that way to restrict this diagonal movement. Okay. So from the images, I can guess that we have two support reaction and one reactive moment at A. We have a support reaction, and this one has reactive moment. So this is the answer. We have a reaction. Since we have a moment here, there should be this one is clockwise rotations. So there's counterclockwise rotations should be here. Even though the textbook didn't show the right answer, but there should be the rotations. All right, that is pretty much it. There is a homework. If you look at the homework folder, there are 3 questions, and each question has 3 points. Submit your work through the Blackboard by next week. Let me see. Is it March 13? Oh, never mind. Should be March 31st by midnight. Okay. Today we covered the support reaction part. So there is action and reactions, active moment and reactive moment. And you guys know how to draw the free body diagram. First, show all the dimensions, which means length and angle informations, which is this step is idealized models, and then we can draw the free body diagram with all the unknown and known force. Thanks for watching this short video. Have a great day.